Okay, so in today's notes, we're trying to derive the properties of logs by exploring what happens if we look at log base 10 of x function. So the first thing you're going to do is go to your calculator and put log x into the calculator into your y equals. Remember that your calculator is assuming this is base 10 because there's nothing for the base written down. So from there, you're going to go to look at the table. Notice how when we have x is 0, I get back error. And if you think about what the graph is for the log function, that makes sense because I have a vertical asymptote when x is 0. And remember, the log function is an inverse function for the exponential function. So when we're looking at our table, we're saying that 10 raised to some power gives back 0, and no power gives back 0. This one is saying 10 to the 0 power gives back 1. So remember, everything is inverted because that's the nature of log. It's the inverse of the exponential function. All right, so from here, what you're going to do is you're going to fill out your values into the table here. We're going to round to 3 decimal places. There are a couple of points where we have to jump values, and if you want to do that on your calculator, we're going to hit the second window, and then here is a table start, so you can jump to 100 if you want to, or to 90 or whatnot, and then go back to your table. That way you don't have to scroll around a lot. So go ahead and fill that out. All right, so looking at your table of values here, the next thing we're going to do is explore what happens when I do log of 2 plus log of 4. So from your table of values, I know that log 2 is 0.301 and log 4 is 0.602. If I add those values together, I get back 903. And then finding that value on my table here corresponds with the same as log of 8. Doing the same for this section here, I'm going to go to the table, look at the value of log 6, look for the value of log 5, and then find on the table what that's equivalent to, and I notice that it's the same thing as log 30. And when I do it for log 9 plus log 10, I notice that's the same as log 90. And log 3 plus log 20 is the same as log 60. And log 8 plus log 10 is the same as log 80. So hopefully now you're noticing some patterns of what's happening with my argument. So here when I have logs of the same base that are adding together, I'm going to take my arguments and actually multiply them. So if you notice that all of my arguments are now being multiplied. So when we generalize this as a rule, log m plus log n is the same thing as log m times n. All right, so if you had to make a prediction of what's happening when I take 2 logs of the same base and subtract them, maybe you've got a nice prediction that perhaps they are dividing, right? So to check that, to make sure that this is really happening, go to log 8, subtract the value in the table for log 2, and I notice that it's the same thing as log 4. Right? So log 70 minus log 10 is the same thing as log 7. Log 60 minus log 6 is the same thing as log 10. Log 90 minus log 30 is the same as log 3. So in general, if you have the same base and I'm subtracting 2 log functions, then it's going to be m divided by n. Okay, so to see the next pattern here, this is asking us to compute 3 times log 2. This one's saying 3 times log 10. I'm going to start with this one because it's a little bit easier because log 10 I know is 1. So 3 times 1 is 3. So I go to my table up on top and I notice that 3 corresponds with 1,000, right? So that's the same thing as saying log of 1,000. All right, so trying to figure out what the pattern here is, right? I notice that if I take 10 and I cube it, I get 1,000. So really this multiplier up front is actually the power of your argument, right? And you'll notice the same thing when you do the other ABD. So in general, we say that k times log m is the same thing as log of m to the k. All right, so everything that we've just done is we've taken multiple log functions and condensed it to one log function. So this is a word that you'll have to know as a skill, right? So on worksheets or quizzes or tests, it might say condense the following function, and this is what we're talking about, that you took multiple functions of log and you condensed it to one function of log. So all of these are rules for condensing. So to summarize what we've done here, right, remember that log functions are inverse function of exponential functions. So on exponential functions, if I was multiplying like bases, you added powers. And now I'm adding, so that means I'm multiplying arguments, right? Comparing this property with exponential functions, right? If I was dividing exponents with the same base, then I was subtracting powers. Here I am subtracting logs, so I'm dividing arguments, right? Okay, so that's one way to think about it. So the front side, we were working on condensing multiple log functions, and these properties, the product property, the quotient property, and the power property is actually going the other way, which we call expand. So in these, we are taking one log function, and now we're expanding it to multiple log functions. So it's same concept as the front side, but now we're going in the other direction, right? So the other side, we're here, and I wanted this. Now we're here, and I want to get back this. Okay, so let's do some examples like that. All right, so for the next examples, we're asking you to condense the terms. So if we're condensing, that means I'm taking multiple log functions and I'm trying to condense it to one log function. Remember, the first thing you're going to need to do is check to make sure that your bases are the same so that we can use our special properties. So this both are talking about log base 3. So we can rewrite this as log base 3, and since my log functions are adding, that means you take your arguments and you multiply them. Okay, these both have log base 5, so I can condense it and take my arguments and multiply them. Okay, this one that has 3 log functions, right, all have base 2. This one is an addition, which means in condensed form will be a multiplication of the arguments. This subtraction means I'm taking it and I'm dividing my arguments. This can further reduce to log base 2 of 2. And then from our other notes, we've discovered that this log base 2 of 2 cancels to 1. All right, then on number 4, I do have like bases of log base 2. The 3 up front, since it looks like a multiplier, is actually an exponent for this x. Right, so it's going to be log base 2 of x cubed, and since I have an addition here, this means my arguments are multiplying. This one is the natural log. They all have natural log in common. Remember, the natural log is still just a log function, right? So with base e, so we can actually apply the properties because they're all the same base for log. I have an addition, which means my arguments are multiplying, right? And then I have a subtraction, which means my arguments should be dividing. There's a 3 in front of this natural log, which means this part should be raised to a power. So sometimes this helps if you write it right away. So now I have natural log of 4 times 27, because 3 cubed is 27, divided by 12. This is a fraction that can be further simplified. I noticed that I've got this and then this like that, so now I have natural log of 9. All right, then when I rewrite number 6, remember this is supposed to be a power for my argument. So I can rewrite this as log base 7 of 49 to the 1/2 power. Remember that 1/2 power means take the square root of 49. So now it's log base 7 of 7. And this cancels to 1. Okay, so for number 7, remember this is really a power for 64. So I'm going to do some side work first. 64 to the 2/3 power means I'm going to take the cube cube root of 64 first, and then I'm going to square it. So the cube root of 64 is 4, and then I'm going to square it, make 16. So I can rewrite this part as log base 4 of 16. Okay, so now I have two log functions that are subtracting, which means I'm actually dividing my argument. So log base 4 of 16 divided by 8. I notice that this is a fraction that I can simplify. So this is really log base 4 of 2. Okay, so from here, you're not done just yet. So remember how on the other day we were talking about log base 4 of 2. Sometimes you can rewrite some of your bases so that the base matches this, and that would be convenient because then we have some cancellations. Another way to think about this is, remember, log base 4 of 2 means 4 raised to some power gives back the answer 2. So 4 raised to what power gives back the answer 2? And that means I'm taking the square root of 4 to get back 2, so that means my power is 1/2. Another way to look at it is to go ahead and change the base like we were talking about. So you could do log base 2 of squared of the argument 2 equals question mark. When you rewrite this in exponential form, it's 2 squared times question mark equals 2 to the first. Since my bases are the same, my powers must be the same. So what does question mark have to be so that I can have 1 as an answer? And question mark has to be 1/2. So when you simplify this, my final answer is 1/2. Okay, so for number 8, my bases are the same for log, so I can condense this, right? So with subtraction, really it means division, and this 2 up front really means it's a power. So I like to do this first so I don't forget. So we're going to rewrite this as log base 5 of 16 divided by 2 squared, which is really 4. And 16 divided by 4 is 4. So my final answer is log base 5 of 4. And then for number 9, it looks like they don't have bases, but remember, if there's no base written, that means they all have the common base, which is 10. So this is really like log base 10 of 3, etc. So what we've got here is an addition, which means multiplication. This is really a power, right? Subtraction means dividing the arguments. So when I rewrite this, it becomes log of 3 times 4 cubed, which is really 64, divided by 6. This is a fraction that we can reduce. So log 32 is my final answer.